So we've talked about atomic number and atomic mass. Atomic number being the number of protons present in an atom, and the atomic mass being the number of protons plus the number of neutrons present in an atom. We record these two numbers to the right of the letter being used to represent the atom. In this case here we see carbon being the atom, so we put the letter C in capitals. To the right, above, we write the atomic mass, and below we write the atomic number. So if we look at this example and we want to determine the number of protons present in this atom, we look straight away to the lower number, the atomic number, and see the number is 6, thus there are 6 protons present in this atom. In the next example I want to talk about, we have the same atom. This time we want to work out the number of neutrons present. So what we need to do is take the atomic mass and subtract the atomic number, which is to say we take the number of protons plus the number of neutrons and subtract the number of protons to arrive at the number of neutrons. We see here that arithmetic would involve 12 minus 6 equaling 6 neutrons. Now, the number of protons for carbon is always the same, and this is true of any atom. The number of protons makes it that atom. However, the number of neutrons, even for the same atom, can vary. This would result in different atomic mass numbers. So carbon C12 isn't the only isotope of carbon. There are other isotopes. For example, we have also C14 in a lower abundance than C12, but still present on the Earth. And C14, as you will be able to calculate, has 8 neutrons. Another isotope of carbon is C13. And again, with that calculation, you can see that there are 7 neutrons present in that atom. But notice all of them are carbon atoms, just different isotopes of carbon atom. And this isn't just true of carbon, it's true of many other atoms. For example, here we have another very important atom for organic chemists, and that's hydrogen. Hydrogen, the most abundant form, is H1. And here we have 1 proton and no neutrons. Remember, I was talking how protons were present, but neutrons were almost always present. Here's a case where there are no neutrons at the nucleus. It's H1. But this is not the only isotope. We also find in a lower abundance H2, sometimes given the letter D or deuterium. Now with H2, we have 1 proton and 1 neutron, but it's still hydrogen atom. H3 is sometimes known as tritium, and this has 1 proton and 2 neutrons.